Hello and welcome. This is question 6 of the Princeton Final Exam Review. My name is Jerry and I am doing most of the questions on this exam. So this equation states, in an amusement park ride, riders are pressed against a wall that revolves in a vertical circle of radius r equals 5.00 meters, and angular velocity omega equal to 1.6 radians per second. Determine the force that the wall exerts on a 60 kilogram rider at the A, top of the loop at point A, and B, bottom of the loop at point B. Now, I have some known values here. We have r, we have centripetal velocity, we have angular velocity, and we have the mass. Well, for equations, you can see them here. We have the centripetal acceleration, v squared over r, which you can find in the top left, kind of in middle, top left middle. And we have v equals rw, which is in the top middle. And with this, we know that centripetal force is going to be equal to m times centripetal acceleration. And we could take it a step further and say that the centripetal force is going to be equal to m times v squared over r, and even further, and replace v by rw, or centripetal velocity. No, I keep saying centripetal angular velocity divided by r, which is simply going to give us mrw. Okay, now that we know that, we can begin to solve the problem. Now you notice that in this image we have 2 points. We have point A and point B. And in both points we have two forces that are acting. We have the force that is the centripetal. We have the force, the centripetal force, which is the force of the motion of the ride spinning. So this force pushes the person into place. Well, there is also the gravitational force, and you can notice at point A, the person will be upside down, so that gravitational force would push downward, while at B, the gravitational force would still push downward, but it would push downward onto the loop. So it would be negative at the top and positive at the bottom. So we can do that quite simply. So if we go A, we know that the force is going to be equal to the centripetal force minus mass times gravity. And this would give us 180 newtons. Centripetal force being this guy. While for B, we have the centripetal force plus gravity, because it's pushing onto the ride rather than pushing off of the ride, off of the wall. And the question specifically asking, determine the force that the wall exerts on the rider. And this gives us 1,360 newtons. And that is the answer. One other thing that might be of interest is that in the first question, part A, if the force of gravity was greater than the centripetal force, the person would fall off. So if it's 0 or negative, then that would mean that the person would fall off of the ride. They would not be stuck to it. Well, for the other side, other thing, it doesn't really matter for B, because the person would still be laying flat on, a vertical surface. And that's that. I hope you enjoyed it. We'll be doing more questions in the near future. Thanks, and have a good one.